talking about GCF and LCM and how they're different, how there are some similarities. The big thing about this is that when you hear GCF, greatest common factor, you're not actually looking for the largest number. You're looking for the smallest possible number that can go into both of the numbers, or sometimes three numbers. Lowest common multiple also goes along with lowest common denominator. You're actually thinking that you would probably look for the smallest number. You're actually, it's true, but it's going to be larger than the numbers that you're given in some cases. So I want to break that down for you today. I have a really good method. We call it the birthday cake method. Some people call it some other different things, but it works great. We're going to look at the vocabulary, which will help us out. Otherwise, it's going to be helpful for fractions, division, factoring, all sorts of stuff like that. So I hope you enjoy it. It's going to be a good one. All right, before we jump into any problems, let's take a look at the words greatest common factor, which is GCF, and lowest common multiple. So this is where the confusion comes in my opinion. So let's say that we have two numbers, 12 and 24. We're looking for the greatest common factor. Well, factors are smaller numbers that compose these larger numbers that can be multiplied together. All right, we talked about that in prime factorization and factoring. So you would think that the number is going to be larger than the two that are given. It's actually smaller. So we're looking for the biggest number that can go into both 12 and 24. All right, in this case, it actually ends up being 12, and I'll show you how we got to that in the next part. Lowest common multiple. So if we go to 12 and 24 again, all right, you would also think that that's going to be the smallest number by the word lowest, which is not the case. All right, the lowest common multiple, think of common denominators, is a number that both these numbers can go into. Not factors of these, but numbers that these numbers can go into. Well, I always state that you should look at the larger of the two. 24 and 12 can go into 24. Some other numbers you can look at is 12 and 15. All right. The largest number that can go into both of these is 3. All right, we'll do 12 and 15 again down here. All right, the largest number that these two numbers can go into would actually be 60. All right, and I'll show you how we got to that in a minute. All right, what we're going to use here for our GCF is what we'll do first, is the birthday cake method. All right, and I'll show you how that works and why it's called that in a little bit. But this method works for both GCF and LCM. So we're going to do both. All right, so we'll do these side by side. That way it's a little bit more clear. So we're going to do the GCF first, and then we'll do the LCM next. So what I do is you put this little step here. You're going to see that it's going to look like a cake in a minute. So you start out with your lowest numbers. You're not going to use 1 because 1 just repeats itself. So we'll start with 2. 2. Can 2 go into both 12 and 15? Unfortunately not. It can only go into 12. So then we go to 3. So we see that 3 does work, and it's almost like two division problems here. 3 times what got us 12? Well, that's 4. 3 times what got us 15? Well, that's 5. All right. There are no other numbers that can go into both 4 and 5 evenly, so we stop here. All right, and because we stop there, 3 is our greatest common factor for 12 and 15. Now we're going to do the same two numbers again, but now look at the lowest common multiple. Obviously, we'll start with 3 again, and then we have 4 and 5. And as I said before, there's no other numbers that can go into 4 and 5. So instead of just taking the 3, you're going to create this, which almost looks like an L, right? Looks like an L, kind of a silly looking L. We're going to take all those remaining numbers and multiply it together. So 4 times 3 is 12. 12 times 5 is 60. And boom, it's just like what we said from the previous slide. All right, let's do that again with two different numbers. All right, so we'll create our little slide there. And we're looking for GCF. So we go 2. And 2 works for 72, but not for 27. 3 actually does work. Now, you could use larger numbers, but I like going small just to kind of use it for instructional purposes. 3 times 9 gets us to 27. 3 times 24 gives us to 72. So if we look, we can actually use 3 again. All right, 3 times 3 gets us 9. 3 times 8 gets us 24. All right, so what we're going to do here, we didn't have this last time, but we have these two remaining numbers. So we take those and multiply them. Remember, we are not doing these bottom numbers here, okay? So 3 times 3 is 9. So that would be our GCF for 27 and 72. We'll start over. Obviously, we're going to get the same results. 9, 24, use 3 again. 3, 8. Now, in this case, we're going to take all of our numbers here. So we have 3 times 3 times 3 times 8. So we get 9, 24. 9 times 24 ends up being 216. So that would be our lowest common multiple. And once again, where the confusion lies, greatest, you would think this would be bigger. It's not. Lowest common multiple, you would think that would be smaller, but it's not as well. Well, let's see how this works with 3 numbers in a set. So we're going to take the same approach. All even numbers, let's start with 2. It's like saying you're taking half of each of these. Right? Even numbers again, we'll do 2 again. 4, 7, 12. Now, here's the issue. 7 is a prime number. So we're going to circle that, right? And then he's just going to stay with us. All right, so we go down. All right, so once we stop here, looks like the biggest number that can go into all of these, because once we have this, we're not going to be able to go any further. Once we have this one number that's out, it's not going to work. All right, so we'll just take what's left. 2 times 2 is 4. So our GCF for 16, 28, and 48 is 4. All right, and that will cause that is that the stoppage here. Now, this is where it's a little different with LCM. We have half our work done for us. So we take half, 8, 14, 24. We'll do that again. We have 4, 7, 12. Now, remember, we stopped here. All right, we stopped right there. So what we're going to end up doing is, keep going. The 7's just going to get brought down each time. So 2 goes into 4 twice. It goes into 12 6 times. 7 gets brought down. So we can go again. 2 goes into 2 once. 7 gets brought down. It goes into 6 3 times. All prime numbers are remaining. So we're going to do 2 times 2 times 2 times 2 times 7 times 3. And I don't need that 1 because I'm just going to repeat myself. And after we multiply all that together, our lowest common multiple is 336. All right? Much easier than going through trying to figure out which one would work for what. Multiplying and all this, it's a bit more straightforward. All right, here's a real-life approach to these types of problems with GCF and LCM. It says, Mr. Small's 7th grade class is competing at field day. He divided the class into the greatest number of teams possible with the same number of boys on the team and the same number of girls on the team. So we need to figure out how many teams were made, how many girls were on one team, how many boys were on another team. All right, so what we're missing here that I failed to put in is that there's 16 boys. Let's pick 16 boys and 12 girls. That part's obviously important. We're running out of room there. All right, so what we're going to need to do is, this is our clue that we're going to be using GCF. So we got 16, 12. All right, let's go with 2. We'll start even. 8, 6. 2 works again. So then we have 4, 3. All right, and we got to stop there because there's nothing else because we are looking for GCF. So we have the greatest amount of teams we could have is 2 times 2 is 4. And this was the boys. This was the girls. So all the work is done. Boys equal 4. Girls equal 3. All right, if you ever saw the movie Father of the Bride, this is a great LCM problem right here. So it says he goes into the store and he gets all upset because the hot dog buns come in groups of 12, where hot dogs come in containers of 8, which doesn't make sense because they should match, you would think. So what we're going to do is we can see that this is going to be an LCM type problem. All right, we'll start out with even numbers again. 4, 6, 2. We have 2 and 3. All right, and we stop there. So this was our hot dogs, right? So what ends up happening is when we break this down, we take these all together, because remember LCM, you're going to make that little L, 2 times 2 times 3, ends up giving us 24. So the magic number is 24. So if there's 8 hot dogs in a container and 12 buns, the common multiple would be 24, meaning that you're going to need 3 of these, 3 containers of this, and 2 containers of the buns, or 2 bags of the buns, in order for it to work out and be even without any waste. Hopefully you have 24 people to eat all those hot dogs though.